9:30 on time. Pretty full house, nice. I was not expecting so much people, making me a little bit nervous. But I'm Marek. I'm representing here experience in separating monoliths to cloud-based service-oriented architectures. And I'm talking about our experience in Fortuma, who is a payment processor, and we are essentially processing mobile payments in the world. So today, what I'm going to talk about is what does it actually mean in introducing the microservices to a company which has been very much used to building a monolithic application. The background is that our current payment platform is almost 8 years old. Built pretty much from scratch from the time when Fortuma was founded. And then I cover a little bit of a choice between HTTP versus message queue-based microservices. So we had to make that choice quite early on when moving on with our architecture. What were the considerations? And we did choose the message queue. So I'm going to cover a little bit of the technical aspects that are coming from message queue, its operation, and the software development, especially in the distributed services. And I'm also going to talk a little bit our choice of a technology change, because we are transitioning from Ruby to Java-based microservices, and what has been the rationale behind that. And finally, I'm going to take a look into this and try to cover bits and pieces whether it actually has been worth the investment we have been making. So, just quick words about me. Today I'm running the engineering at Fortuma, which means that I'm responsible for overall software architecture and infrastructure. My previous background comes actually from different cloud-based services. In different aspects, I've been doing networking for Skype for 8 years, and before that I was doing mobile services. And I've also have experience in custom solutions, both based on pure HTTP-based microservices and also pure MQ-based microservices. And yeah, interestingly, majority of my work has been revolving around quite high volumes, low latency type of offerings. And as funny as it might seem, then actually call signaling and payment processing aren't actually that much different from each other, especially from the latency aspects. But starting on, just a couple of words about the monoliths. So Fortuma today is processing payments in 94 countries. This means that we are able to offer payment services for the merchants who are using us in 94 countries. And as I said, our current payment architecture has been evolving over the 8 years when Fortuma was started. And it's built on top of Ruby on Rails. And Ruby on Rails tends to sort of thrive towards the monolithic application structure. So it's actually a very good choice for a startup, pretty much for the reasons of architecture being very simple. So you can create all the modules, controllers, views, everything in one place. The application itself is quite self-contained. Tooling is pretty okay, so the development cycles actually in a stage where the company is growing are very fast. And you can crunch out features very quickly, you can make modifications quite quickly, and actually it's quite okay choice for the starting company. Now the trick is to understand where it stops. And the issues we have been facing over the years is that the monolithic applications such have tendency to grow very quickly to an unmaintainable state. This unmaintainable state means that if you have a developers team, 20 guys coding on the same code base, who have to release, deploy, make changes to this system, this is getting complicated. And it's very easy to start taking shortcuts, no matter how hard you try, but you figure out that I need to implement this or that type of business logic. I just make a workaround, I access directly the database instead of going through the model. Also, a lot of people usually working in different stages, different competencies. So getting quite unmaintainable. And also the scaling of the application itself becomes very hard. We are today in a very heavy transitioning state, so our volumes are growing tenfold, something like this in the areas, in a half a year's time. So Monoliths application usually is scaling up. You just buy bigger servers, you just buy bigger servers. At the same time, releasing verification and actually scale out of the services becomes quite complex. And since we are operating globally, we are actually interested in being as close to the customers. And we also have to deal with different types of regular things that are happening in the world, like DDoSes and so on, which are quite hard to mitigate for a single endpoint. And some other takeaways which we have seen is that, as I already pointed out, the coding style in the teams, no matter how much you try, no matter how much you try to enforce it, it deteriorates and makes the overall architecture a mess. So I've seen it actually in all the places where I've been working, that even if you start out with very good ideas, very good clear separations, interfaces, and so on, business usually will drive in at some stage, and not in a bad sense. But there is always a pressure, and you always try to find a quick and dirty solution. And this makes actually the code base quite a mess to maintain. Hard to test, hard to debug, there is usually very little comments. You will be asking a lot of questions like, so we made this kind of thing here, why? Nobody knows. Maybe the person who wrote this has already left the company also. And the other thing is that the development organizations and the code bases actually evolve and tend to drive themselves around the microservices. And I've seen it twice. I've seen it in my previous workplace and also in Fortumo. And this actually has been stated pretty nicely by Conway. It's known as Conway's law, which essentially states that software and the design tend to copy the organizational structures. And if you have different teams dealing with, for example, end consumers, back office, for us, the payment providers, the operators, the overall software architecture tends to grow around that model. So you will have actually a team which deals mainly with back office things. You will have a team which deals with payment providers. You have a team which deals with the transaction processing. And if they all are dependent on the same code in the same code base, this actually makes it quite hard to develop. So for a year and a half, we have been working on splitting up our existing application. We are not fully rewriting it from the scratch, but rather splitting it up to a microservices based. And based on this background, the first thing that we had to deal with was the choice of the architecture. So essentially, if you speak about microservices today, this is pretty much the earliest choice that one has to make. So it's an early decision, even before you really start writing all the services that are doing different things. And today, it basically boils down to two different architectures. So you either go down the HTTP route, so all the services are HTTP based, or you go down the message queue route. And I've been using in my work life, both of them, and they both have their good parts and their bad parts. So HTTP is really good for things like throttling. For example, if one of your applications goes nuts, starts overloading the other ones, it's actually pretty easy to throttle. The load balancers are pretty efficient today in handling the HTTP-based connections. For example, we are purely Amazon-based. And this means that the Elastic Load Balancer actually works very, very nicely with all the HTTP-based load balancing. tolerates very well data center distribution. So you can have services running over multiple data centers without much consideration into their performance, because usually HTTP is quite good at that. It has also its downsides, which is that connections that are made between the applications usually grow the socket limit. Also, you definitely need service discovery, which is quite complicated. So the other choice today, which we have decided on, is to go with the message queue. The good parts of the message queue and the decision for making that choice for us was that it provides really good concurrency handling because the queue allows to have multiple consumers, so concurrency gets a little bit easier. Puts quite a good and strict separation on the messages and the content which needs to go in. I'll get back to that a little bit later. And is really good for asynchronous services. So today our architecture pretty much is fully asynchronous. So we have a couple of endpoints where the client requests are coming in with HTTP and which are from client's perspective synchronous requests. But actually, the rest of the backend is fully asynchronous, running on an MQ, and performs actually very well. So, from our experience over the last year and a half now, the good parts which we have noticed so far, actually, when I was asked to write down my subject for this talk, a half a year ago, we were actually originally considering focusing on service discovery. And for me, the good part and the bad part is that we actually still have not required any service discovery as such. The reason is very easy. Consumption is the problem of a consumer, not the publisher. So if a service creates a message and expects something to happen to this, it can just put it to the queue, and that's it. It doesn't need to know anything else besides where the message queue is and how can I access that. So there is a bit of service discovery, but not in a scale of I need to look up different services and so on. Rather, it is the problem of the consumer to know that if I need to do something with a message which is sent to me, I need to listen to that exchange or queue, and you can have multiple listeners which do different things. For example, we have two different paths in our infrastructure. One is a transaction path and the other one is an accounting path. One is a real-time system because you don't want to really wait very long for your payment to go through, but actually calculating taxes, shares, all that doesn't need to happen in real time. And you can have two completely different systems listening for the same messages. Also, the really good thing that comes with the message queue is that pretty much all the communication is asynchronous, because you can, yes, indeed, do RPC-style stuff with RabbitMQ, which we are using, with also probably other MQs, but it's still meant for, like, you put the message into the queue and somebody will take care of that. And this means that it forces you to actually build your overall architecture from day one as a pretty much asynchronous architecture. This actually is a very good thing because all the components are separately scalable horizontally, and the MQ also can handle a bit of rate limiting. I'll get to that, but that's not like really in the level of HTTP, which can become also a problem. And what we get with the message queue is usually we can get some guarantees of delivery. Although Rabbit, for example, and MQs in general are known not to 100% all the time guarantee all the messages, you still get acknowledgements. So if your processing application crashes for some reason, the next node that comes up can continue where it started. There are dead letter exchanges where the unprocessed events will go. And this brings the reliability quite a bit up for us, especially considering that we are a financial service provider, which means that you really don't want to lose people's transactions. Now the complicated parts, what we have seen so far, is that pretty much the most complicated thing to handle is the concurrency. Concurrency requires completely different mindset into how do you build your applications. Because synchronous applications, you create an event, it runs through the whole system, you wait for all the states to be in a correct order, you receive an answer, is easy. Now, we are dealing with issues where the same payment can go through the pending and charge states in very short time frames, and these can be processed by two different nodes, which means that we need to deal with issues where databases can go out of sync, so you can have a charged event coming in before the pending has been acknowledged. So it's not easy. Concurrency is hard anyway, but MQ by its nature, as you have multiple nodes usually consuming, makes it a problem from day one. And the other big problem is the state management. So essentially, as the nodes that you build, very high concurrent nodes, don't contain any state. Usually the state is outside, either stored into the databases, but database access is expensive. You have to think really carefully through the state management. So our approach has been that there is actually quite a bunch of metadata that we are sending with all the messages that go through the systems, and different components actually know how to handle those metadata components that are provided. Essentially, the key thing is that you don't want to make double payments because two components get a message which is in a specific state and decide that, oh, I can handle that, and I'll make a charge, and I'll make a charge, and then suddenly the customer is charged twice. And one of the easy solutions which we have actually dealt with is that, okay, we can serialize out all the access, so essentially all the messages are processed in a serialized way. It's an easy solution, but we have seen quite significant performance drop through that, and we have decided not to try to work on that, rather actually fix our state management and serialization issues. Requires quite a lot of thinking, but the benefits actually are quite good. So essentially, some of the problems we have been dealing with is that there was two components. One went live a little bit earlier, the other one a little bit later. I don't have the exact screenshot, but essentially the unacknowledged message count was 200,000. So what do you do? Because these were messages that we should not drop neither. And essentially, we have our own abstraction of a rabbit driver to make it easier to use from our own components, and we didn't have any prefetch limits there, which essentially limits how many messages you take in from the queue to processing. So the first component that was able to process these messages started to process all 200,000 at the same time, which probably does not end in a very good result. So there are things like make sure that you don't also kill your own consumers by asking them to do quite impossible stuff. It seems to be a small oversight, but Rabbit was fine, and the driver itself was fine, so they just started consuming it, and yeah. Unfortunately, the queues we are using today, are acknowledged queues, so all the messages need to be acknowledged, and we didn't lose any transactions due to that, but still it can create quite a mess. And then the hardest part for us so far has not really been writing code. Writing code, I'll get to that a little bit later, is actually very easy. If you get to the microservices, we have seen that majority of our time has gone to agreeing on the messages, message types, message contents, and pretty much the semantics of the messages. And And what makes it really complicated is that we have quite loose teams. So we have pretty much 4 engineering teams who are all delivering their own components. At the same time, for example, the payment transaction goes through all the components. So there has to be a unique understanding on all the details that are going in and coming out of the messages. And actually, the code example here is taken from one of our messages. And there was a component which needed to map some information for some other component. And we have a public UUID ID. So, okay, cool. Was it global running operation across all the components? Was it a specific transaction? Was it component-specific ID? So ironing this out from the messages took like a week because there actually turned out to be a lot of places where you just need to change things. And our consideration right now is that during the early stages of the architecture deployment, around 50% of time actually went into agreeing on the semantics, on the content of the messages, on the overall logic on how the transactions work. Once you get that nailed down, then writing the code itself is quite straightforward. So yeah, that has been for us one of the most hardest parts. If we would have chosen the HTTP-based services, then it would have been simpler because usually the messages don't go through directly all the systems. The mappings are easier. But right now, if you have multiple consumers, you don't know who your consumers are. These are the things which need to be way more strictly agreed on. And then going on to our microservices part, as I mentioned earlier, we are transitioning today from Ruby to Java. It's been an interesting choice. I know that this can be one of the most opinionated debates usually in the rooms, but today we have made that choice and it actually has turned out quite well for us. And the reason is that we are using very, very lightweight services. So we don't do any of the Java 2E stuff. Our application server today is running on Jetty as a container, and from the Java 2E whole specification, we are using pretty much 2 things. We are using the servlet specification and JPA, and even there we are not using Hibernate or Eclipse Link, but MyBatis, which is actually quite lightweight. And we have seen quite tremendous increase in the code quality and actually even in the productivity compared to the Ruby. Main things are that Java 2 SE framework has pretty much all the required functionality that you would need to implement any type of business logic. You don't usually need any third-party libraries. You even don't need to write these days too much of a boilerplate code. Some other things we have done to make our microservices easier is that all our external libraries, so we have a logging, configuration, Rabbit driver, and like a base application, we are putting in through injection. So actually the base service is maybe like 4 or 5 Java classes and a couple of 100 lines of code. Works very efficiently. And for developers, that's like my view from as an engineering manager is that setting rules is making things actually easier. So there is no ambiguity in the stuff that you're doing. Types, yes, they are inconvenient because they are not dynamic and you have to know and you have to declare them. But then on the other hand, you don't have issues where somebody is logging down strings into your Elasticsearch, which we're using as our log backend to a type, and then somebody else tries to log an int there, and half of your messages go somewhere because somebody forgot to put to string. Also, the development tools, deployment tools, and things like this are significantly better. Again, very opinionated topic, but that's our current experience. And Jetty as a container, yes, we don't use any big ones like Glassfish or so on, but rather Jetty, usually our setup is just running it from Gradle directly. And I just yesterday, to show the performance, was making some measurements on my own. I hope that the presentation will be available later also, so if it's hard to see, but pretty much this is a microservice which is consuming messages from RabbitMQ, running on a 1 CPU, 1 gigabyte Hyper-V virtual machine, and it's being loaded with 200 messages a second, pretty much steady load of messages for processing. And the average heap usage for the whole Jetty process is 32 megabytes. So yes, we have had like quite heated debates around why don't we use Spring, why don't we use any other big frameworks, which would immediately bump it up to like 400, 500 megs. Today, majority of our microservices are running actually in Amazon T2 micros. So these are the smallest instances that you can get with 10% of CPU limit and 700 megs of RAM. And our performance shows that we can pump through actually 50 requests a second through the whole system. And this is pretty much a single node system. So the performance for us has been quite amazing. I'm quite certain that you can get similar numbers out using other technologies too. But making them perform and having tooling available is quite significantly bigger problem. And the other thing which I wanted to show is today doesn't have much labels. I was asked to redact them out. But this is our existing current production infrastructure. So we have actually quite many components. And this is actually today processing our payments. As you can see that we have been taking actually quite wild step in that we essentially said from day one that every single functionality has to be a single instance, single node, doing just one thing. We slipped. We put two components together. So one of the things which seemed quite obvious, making authorizations for charges and actually processing the charges, we had them in one component, was not the greatest choice because we had to spend around a month to separate them out under production load. Quite strictly, keeping the components separate from day one gives a huge benefits. And also the other thing which, at least from our experience, I would recommend to do anybody who's starting dealing with MQ is that don't go into the production with single instance. Setting up high availability clustered Rabbit is actually not that high. Moving from single instance to a cluster under a load is actually a problem because you have to shut down that single instance. And we are doing that step right now. The scenarios that we have to play through are actually quite complicated. There was like a quite urgent production need for this. So don't do that. Rabbit just doesn't allow, even if it's like a single node running, you cannot tell it suddenly that, okay, you now have to be clustered and I can start adding you other nodes. You actually have to take it offline, put it into the cluster, and then boot it up again. And doing that under like actual processing load is difficult. So we are using also elastic load balancers in front of the Rabbit, which are doing for us the liveness checks and distribution of the load. But still, we have to switch from one instance to the new cluster, and it's complicated. And one of the most interesting things which I actually wanted to tell about this slide is that if you take a look into the databases, then this is one of the biggest benefits that we have right now reaped out of using the microservices is that you cannot take any random of these components and go digging into database of somebody else. So this actually has enforced data integrity and from day one. And this removes a lot of issues where somebody has a temptation that I know that this piece of data is there in the database and I know how to connect there and I can just look it up from there. And then that other piece from that other database, and suddenly you have like 2 A4 pages of SQL doing stuff. Yeah, you cannot do that here. And this removes so many problems. This actually enforces you to think that, okay, so if I have to authenticate the user, it goes to the authentication component, this does its work, has its own data sources, gives me back information, and if they want to change the data source behind that, it doesn't break anything else. Yeah, and then we have a bunch of internal applications which actually are using the data streamed out of the whole system, like monitoring, reporting, alerting, and so on. So, pretty much the biggest thing for conclusion is that by going to very small independent services, we have significantly reduced the complexity in the overall system. If you have, let's say, 20, 30 developers writing the same code base, same application, same models, same controllers, this is actually complex. We are doing today 3-4 releases a day, even with our existing infrastructure. But this has also meant that we have a dedicated person every week who's a release manager who takes care of today more like a supervisory role, but make sure that whatever gets deployed is actually working and verifies that all the required components are coming up. And has to know pretty much a very detailed view of the overall transaction processing system. And that's complex. And there are very easy ways how to make mistakes there. Strict decoupling. You cannot build microservices architecture without decoupling services from each other. MQ, as I said earlier, also has forced us even harder to decouple the services from each other and has forced us to really put as minimal functionality into each of these applications as possible. And this means that the applications and the business logic inside of them is easy. It's easy enough for even me, who is actually not everyday coding, to understand each of the components, to understand their internal workings. And it also reduces the application footprints. So instead of having actually quite big machines that you need to deal with, the application footprint right now and the scale that we are getting is quite good. Although, yeah, to admit, our Rabbit machines are indeed running on a medium-sized servers, but that has been just like consideration of what happens if you have a heavy load and then it runs into the CPU limits and it kills it, which would not be a very good situation. But today we haven't seen actually the Rabbit also reaching any of the micro limits. Architecture in front and building in front takes way more time. And that's why in a very rapidly changing and like a startup-ish environment, this can be an issue because you need to lock down the architecture quite early. So we have probably around 23 messages going back and forth in our system. And somebody has to actually go and make sure that every component understands them the similar way. So if we have a created at time, this has a common meaning across the whole system. Created at does not mean the created at of the specific message, but maybe it's about the transaction. So you need to agree upfront on these things. And usually it seems for the whole dev team also that we are spending so much time in the meetings just like debating around how to name stuff. But once you get all that done, we've seen that the implementation of the whole system was pretty much done in, I don't know, we spent like maybe 6 weeks thinking, and the other 6 weeks of just like pure execution. It was very rapid. And yes, it had bugged initially, but fixing those was quite easy. And as I mentioned, the MQ is a critical component and requires care. So time will tell whether our choice was a good one or a bad one. We definitely are satisfied, as I said, with the fact that we don't have to deal with service configuration and discover in a sense of understanding where are all the different nodes deployed, because MQ usually takes care of that. But it has its problem. MQ Rabbit definitely doesn't tolerate network partitioning. So this means that we cannot run the same cluster in Dublin and Frankfurt. We have a cluster in one location. It's of course spread over the availability zones, but still, like in case of like Dublin outage, complete outage in Ireland, we would have to route all our traffic from one location to completely to another one. There are tools available which are pumping messages through the systems, like Shovel for Rabbit, but the latency issues will still be problems, and it will have issues with acknowledgements and so on. And for me, the Rabbit was kind of like a good choice. The documentation is actually quite easy. Although it's running on Erlang, which is not the most common language in the world, it's performant, works quite well, but it has its caveats, and it's not as widespread as HTTP, so having issues with HTTP-based components are usually easier to solve than with an MQ. But in general, I think that so far the path we have taken is bringing us actually quite significant benefits in the speed of delivery and reduced complexity in a sense that the developers are much more confident in building the overall system. Yeah. Questions? So essentially, the only versioning problem that we have is with the interfaces that we are exposing outside to the outside world, which is pretty much only one interface right now, which the merchants are using. Today we have taken our stance in a way that we are, if you're pumping up a library, we are pretty much pumping up everything. Yes. Yeah. Since we are based in the cloud and we have advanced quite far with our automated deployments, usually what we do is that we just gradually upgrade all the nodes. Of course, must admit that we haven't done very major breaking changes, which would mean that the two components would be unable to talk to each other completely. That would be a little bit more bigger challenge. But then on the other hand, we've also seen that keeping the backwards compatibility doesn't bring that much benefit. So it's easier to take a hit and upgrade everything at the same time than keep multiple different versions. And then, again, from my previous experience in many places, there are people who don't want to move on because they are used to doing something in a specific way, and then you will have a lot of components suddenly which you start to need upgrading anyway when you deprecate stuff. So that's our solution to versioning today. External, we have actually versioned API, and we are doing internal mappings there. And the external APIs for us are HTTP-based APIs, so it's a little bit easier. Yeah, it's pretty much we try to take it down to the smallest piece of functionality that you can take. So if you have a tax component that you need to calculate, then put it into a separate service. If you have a gateway, sort of like a money calculation component, put it into a separate service. If you have, I don't know, authentication for us is definitely a separate service. Transaction storage, separate service. No, we are using Debian packages in production. So old school, not really new and hype, but then works quite well, allows to put in also the dependencies and things. So. Yeah, every component is built independently. Mm-hmm. Each team builds their own components, and actually when they are ready, then they are upgrading. So we are out of time officially, so if you want to ask me questions, we can continue here, but yeah, short talk, huge topic. I could go on for days on this one, but yeah, if you have any questions, I'll be around here until the evening, so, and tomorrow too. Thank you.